So our next speaker is Scott Fox, Senior Technical Advisor to US DoD, Office of the Undersecretary of Defense for Research and Engineering. Scott Fox is a technical advisor at the US Department of Defense, where his focus is on how 5G can transform America's national and economic security. As a 40-year veteran executive of the wireless industry, he has also been entrepreneur in residence at the University of Colorado Boulder since 2018, bringing his experience to bear on the university faculty and students that are seeking to commercialize university technology and intellectual property. Please welcome Scott Fox.
Thank you.
So you got a clicker left and right, and the hand tool, if that's okay.
Fantastic. Thank you. Well, good afternoon. No, that sounds great. Thank you. Well, good afternoon. It's nice seeing some very familiar faces and then some faces I don't recognize at all, right? And so I think many of you have been performers on the DoD experiments over the last several years, and we've had lots of them, right? So I was going to quickly cover a couple of those just to put things in perspective for those who might not be familiar, but I primarily came here to talk about the importance of open systems and open software and its importance in terms of transparency, the ability to leverage a broad, intelligent community that we have in front of us to really move things to the next level. So, but first, I thought, you know, as Paul said, my background, I've spent 4 decades on the commercial side of things and was the chief technology officer of a big mobile operator and represented them at the GSM Association and was chairman of the Global GSM Association representing wireless operators. So I've spent a lot of time in that world, and I'm just thrilled and humbled to be here because the DoD has recognized the importance, finally, of leveraging the incredible power of the commercial technologies out there, namely the 3GPP family of technologies. And I dropped what I was doing and ran when I realized, you know, the DoD is really investing money, not quite enough, not soon enough, but as much as they are, you know, we're here to drive it to the next level, right? So I thought if you know much about the DoD, it's almost impossible to get slides, public slides, releasable. So it's not necessarily a purpose-built presentation, but it is quite a bit of insight into our newly focused roadmap. So I thought that would be of significant interest, and I'll talk about a lot of the points, you know, as we go through it. And so again, this global standard, right? The global economies of scale that it can bring, right? The DoD can no longer, I mean, we're a small player in a very, very big world, right? We're proud to have invested, you know, close to $1.5 billion over the last several years. But, you know, our carrier, our mobile network operator partners will spend $10 to $15 billion a year just on tech refresh, no less. And so we are a very small drop in the bucket. So we have to find intelligent ways to really leverage the capabilities. And it's easy to do. This global standard, now that the two paths have come together some years ago, we can truly leverage this, you know, and get this multi-generational benefit of this intellectual capital that's been put into this family of technologies, right? So let me just go to this. And this is a bit of the DoD kind of you know, thinking behind the scenes, right? And I said it where we decision, you know, on the battlefield, decision superiority, information integrity, timely receipt of information, being able to trust it to make decisions is fundamental, right? And it's everything to us. Perhaps less important on the commercial side. I want to kind of point out some of the ways DoD is very similar. Because, and I'm going to talk about how DoD is quite different in many regards, right? We think that there's an opportunity to leverage this family of technology. We've been doing it for a couple of years. I'm still a little bit tentative to see if the entire DoD is behind us and bought into this concept. And I'm pleased to say that I don't know that we'll ever get everybody lined up and onto anything, right? But the momentum has shifted, right? And the DoD does not, their first reaction isn't let's go build a custom whatever. It is now, how can we leverage the commercial developments that are out there? And when we find unique capabilities, we focus on dual use. Almost everything we do is focused on what we call dual use, right? A use that benefits the warfighter, but only if there's an analogous commercial use case, because we want the feature to be utilized. We want it to evolve over time. We want it to be supported and not stranded like so many of our developments when bespokely built are over the years, right? So with that, I can't quite see the deck here. I've touched on the third bullet, right? That the industry globally spends so much more money than us, and we think we can readily take advantage of those developments, right? Our goal is to develop a fully programmable network fabric, right? And we believe the current technologies allow us to do that, right? And I'll talk more on some of the unique needs that we have, right? But we're thrilled about the RAN intelligent controller, the ability to have intelligence at the radio layer that can give us innovation, where we can innovate when and where we want, not necessarily wait for the broader world to line up and agree, and have a couple of proprietary development shops agree with this as well, right? To share just a little bit more, those who have tracked us very closely know that for the last 3 years, we had some pretty big initiatives. We had, depending on how you counted them, 12 to 16 large-scale prototypes on military bases, right? This was done to get us familiar with working with industry, to bring them onto our bases, to learn how we do that, right? To figure out how we deal with the security issues, get them used to speaking our language. It was not easy, right? We burnt lots of calories doing that, and made some foolish mistakes, but moved up the educational chain, and it was mainly and primarily an attempt to build a more robust U.S. industrial base, and by bringing in non-traditional performers that and so this was a big step for us. And as I look back over the last 3 years, many of you in this room, have become non-traditional performers for us, and we're really excited about that, right? We also spent a lot of time on an initiative, and I'm setting the stage to talk about the 23 shift, because we've recently elevated our gaze and are looking further down the road. We had these big tranche activities, these big 12 prototypes. We had significant initiatives with federal labs, with university systems, looking at operate through scenarios, rapid network assessment tools, and the ability to, as we say, when the military moves across the world, if we find power that is usable, we'll use it, right? If we find water that is drinkable and usable, we'll use it. But if not, we'll make our own. If we come to a bridge, we use it if it'll support our needs. And we think the same thing for communications, and thus our push to really focus on operating through. When you come to an existing network, how do you really understand quickly at the security levels, the integrity of the network, and not just can you use it, but how can you best use it to achieve a specific mission, right? So we also had innovate beyond 5G, which more recently was referred to as our advanced research team, down the road, primarily focused on 6.2 type developments, right? And this was kind of in the first 3 years, and it was good to focus on different tranche investments and to begin to build expertise across these 3 different areas, right? So I just want to, I don't know if anybody's seen some of this, but this is an OV1 that at a high level talks about some of our refined focus on the warfighter, right? If you see up in the upper left corner, right? It's resilient and open communication solutions, right? As I mentioned, everything we do is dual use, right? If we cannot find a dual use for it, it's a custom development, and we're likely to not do it. But we know through experience, if we spend enough time thinking about something, we can more often than not find really compelling commercial applications that are analogous. But this is where we're focusing on lots of work with universities. We're leveraging all the many of the common 5G features or advanced 5G features there in conjunction with the university. We're the MAC ultra low latency, the N3IWF. I mean, just the features that are still coming down the road. Non-terrestrial networking is a really important one for us. Autonomous. If we have, unmanned vehicles, wherever they are, on the surface of the water, subsurface, in the air, high altitude, and they're not manned, it's a very different risk assessment for a mission. All of our assessments are done based on, what is the risk to the mission? Are there people involved? What are the kinds of things that can happen, right? But as you see by just looking at this chart here, and I'm going to go around fairly quickly, some of our needs are very different than the commercial world, right? I mean, our need to be hardened is pretty important, right? Our identity, if our identity or our location gets out, many times that's not a big deal. But on certain missions, that is everything, right? And it puts the entire mission in jeopardy. So the complexities of 5G systems and how the GPS or location information is passed around via mobile apps, leakage there, as we see it, can be, can have very, very serious and negative consequences, right? Perhaps not as much on the commercial side, but certainly, we have a need to be able to and we were just in at Idaho National Labs last week, a big demonstration. Some of you in the room were at our demonstrations where we were showcasing to transition partners a lot of the 5G development, right? And the ability to be able to pull a link to show, resiliency. We have a solution called secure transit over untrusted networks. Pretty easy to pull the SATCOM link, right? But go ahead and pull the software-based, 5G link, right? The performer hesitated for a minute, right? It's not really a commercial requirement. Just shut that link down, right? We have situations where you have to go radio quiet in 1 second, right? So shut down the network. And so reboot times, reinstantiation of the network is critically important to us. Less so on the commercial side, right? There's not a lot of commercial applications where mobile network operators are picking up their core and their mech, put into the back of a truck. And actually, there are lots of those, but many of us don't see it because they're primarily around disaster recovery and those kinds of things that our MNOs help us with, right? Or work with us hand in glove to get done. We have to operate in all domains, right? So SWAP, as we were talking to a few folks beforehand, right? Some of the on UAVs are on a G node B. The size, weight, and power become essential to us, right? As we have war fighters going, downrange, if we can keep them from having to carry green equipment to generate more and more power, if we can do that with less power and have them take less with them, or have microgrid type capabilities, these are all things where, and I'm just trying to point out some of the unique differences that we have, where we have to be more demanding for the kinds of things that we're looking to do. I think there's lots more we can talk about there. Smart warehousing is a great dual use case. It's really important to us, right? I mean, there's a lot of quotes about that where, amateurs talk about tactics, right? And professionals talk about logistics. Smart logistics. If you're in the Army, you think tanks win the war, right? But behind the scenes, most people think that it's really logistics, being prepared, being able to move things quickly, send the right equipment to the right place at the right time. And our current processes are more manual than you would ever want to know, right? So getting into the world of smart warehousing is fundamental. Another key area in anchors, we've shifted away from the accelerate tranches, operate through, and innovate beyond 5G. We're now focusing on 4 to 5 different pillars, one of which is ROCs, or the Resilient and Open Communications Solutions. We have a new lead for that group who also focuses on 6.2 investments. But Dr. Martin Weiss from University of Pittsburgh has joined the team, and a great addition. He's leading that initiative. Ubiquitous connectivity and instant access, right? This is Dr. Dan Massey has picked up on this, but this also, all of these leverage dual use, all of these have expeditionary, all of these have kind of coverage, but generally speaking, we put certain things into that bucket, right? Like high altitude platforms, right? The LEO satellite constellations, the ability to leverage NTN, the things like IAB and other capabilities are really important. So we've been in the process of kind of rebucketing many of these things. Of real interest, we have Lieutenant Colonel Pimentel, who leads this third pillar off on the right-hand side, expeditionary and tactical uses. This is largely a Marine activity, right, where they pick up and they go, right? I mean, if you give them a big piece of equipment, they will leave it behind, right? I mean, it has to be man-packable, has to be able to move. They need to be able to adjust on the fly, and they are leveraging every single aspect that's out there. This third category, and I think as we've been focused on 5G, I believe strongly there's so much more for 5G that's coming. Congress, on one hand, is telling us we need to look a little further down the road, more towards 6G, because they can look at their phone and they see 5G on it. They're pretty convinced we have 5G already, right? So being a little facetious, it's really frustrating at times. But we are also looking down the road at 6G, as we're going to be spending a lot of time on those requirements, but we have a lot more still to do on 5G if we can keep Congress focused on 5G long enough, right? But and this is where integrated sensing and communications really gets interesting. We've done a lot of research in this area, not just with advanced sensors with 5G, but also being able to leverage the network as a sensor, right, to sense the environment around us. And 6G, from a spectral perspective and the physics associated with some say FR3 spectrum, the 7.12 to 24 gig, right? It presents some pretty interesting opportunities for us to use the network as a sensor, right? But integrated sensing and communications is a fundamental part of what we do, and there's a lot to it, right? And I can cover more of that if you would like. But again, we're looking to create, and a lot of what we do has to bring existing platforms and capabilities forward. So interworking functions are fundamental for us, right? So the N3 IWF function of 5G, allowing non-3GPP access, into the network, leveraging, we have in fact, Dr. Rondeau is in Latvia today, overseeing a demonstration to our NATO partners, where we're leveraging a combination with our research partners and demonstrators. We're leveraging a roaming scenario, leveraging what we call PL2, physical layer leverage, right? Where it's basically leveraging this gateway function, leveraging the power of the 5G network capability, and kind of bringing in another proven, what we call LPX, low probability of intercept detection, as a waveform that's trusted by our network partners, so they can get the best of both worlds, right? So there's so much going on out there. We've gotten a lot of excitement by our NATO partners, and it's one of the big pushes for Open RAN, open systems, is the interoperability of these systems, right? We not only have to equip our warfighters, but we're hoping that most wars are outside the US. And in that case, we rely heavily on our NATO partners and other allies to assist us. And interoperating with their systems is fundamental. The software nature of the systems gives us more control, more flexibility to make needed changes on the fly, right? The open RAN, moving more of these virtual functions into the cloud, allows for more rapid reinstantiation, network agility, so to speak, as the situations change. And I'm talking not just warfighting scenarios, which we look at a lot, but we spend a lot of time on homeland defense and on humanitarian efforts, where we do as a nation spend a ton of time rescuing people, going in, and many of those use cases are just phenomenal. We can derive incredible benefit from a homeland security perspective as well. So this is kind of a new OV1. It's intended to look a little further down the road at new spectrum coming, at leveraging these capabilities to the next level, and begin thinking about 6G, which to some is right around the corner. But to others, I just have mixed feelings about. We've got so much good work to do still on 5G. The real valuable warfighter benefits are just coming out in the commercial platforms, right? We're just able to leverage, the IAB capabilities, the side link capabilities for Manet, right, where we can have dismounted troops leveraged off of a common platform, right? The RIC, we're really excited about the RIC, right? But let me just keep going here. Wrong button. Oh, there goes. There goes. Yeah, I thought I've talked about some of these, but this is more just a graphic that could get that can add a little bit more to what I was talking about, right? Up in the upper left, it's ubiquitous and instant access, resilient open comms here, integrated sensing and communications, expeditionary and tactical. In the middle, we have these cross-cutting capabilities, right? That cuts across everything we do. The cybersecurity and security is a big one, right? We have some pretty strong and unique capabilities, and we also want to grow the whole community, right? We think there's some contributions the DoD and the broader government can make to really to benefit everyone. And it's one area that I really do hope we can continue to make some significant contributions in, because we are deriving great value from this commercial platform. Experimentation, right? The concept that we're experimenting, right? We're doing a lot of advanced stuff. It's okay to fail, right? I mean, if you're not failing at one level, you're probably not pushing it hard enough. So we don't see failure. We don't see something not working out as absolute failure. As long as we pick the right targets, we've made an attempt. There's a lot of kind of a few moonshots that just aren't going to work out, right? We want a lot of them to work out. There's some that aren't going to. The open source is key. We've talked about this. When we don't move the market very far. I think the DoD is kind of a first mover in some of the 5G applications. We've contributed a lot in some of the use cases for network slicing. We've worked with our colleagues, across industry and across government in lots of different ways, right? But open source is the open source solutions just do so much for us and it's a topic here today. We use a lot of different code bases. Many of our performers have selected some competitors to SRS, but many of them use SRS, right? So one of the things I think Tiago mentioned this morning, the joint initiative we have, the RFI that's out on the street, right? To create a end-to-end software stack that not just the DoD, but industry and academia can utilize. And we can create not just a research sandbox, but create a more increasingly stable platform upon which to extend our experimentation, right? We think this is fundamental, and we've got a lot of work underway in partnership with other federal agencies. We're very excited to have partnered with the National Science Foundation, with NIST on this. And there's others that I don't know if Tiago had made any announcements. I missed it. I missed that this morning, right? But we have other federal agencies lining up, and we really want to do this right. We have some partners in the room here who have been working very hard on this. And workforce development, right? We probably don't talk about this enough, but one of the reasons where we experiment the way we do, bringing in non-traditional performers and bringing people onto the military bases, right, is so that we can expose, our people to the commercial industry and how you work and your terminology, right? Workforce development is probably our most daunting task in front of us, right? We work, across the landscape to really get the workforce development going. And so each of these experiments has kind of been conceived in a way that brings in a different variety of people from different sources to get them to work in different ways, right? We think that this that the complex problems of today and tomorrow require a diversity of thinking, not just on how you solve the problem, but how you look at the problem, right? I mean, different people look at problems differently. And we're benefiting from that by leveraging academia, industry, and other people across the board, right? Let me switch through this. Is it? This is just a bit of a summary, and I'm gonna obviously dynamic spectrum management is fundamental to us, not just so that we can sell our spectrum to the commercial world so they can use it and make money. We need to move this industry forward, and if we do it in the right way, we can be more efficient with the spectrum that we have. And if we don't keep relocating, and in fact we learn how to coexist, we think that those skills of spectrum flexibility, spectrum agility, and the schemes behind them will really serve us well. And instead of a reluctancy to do those kinds of things, we think it'll be a huge advantage to really find innovative ways to both coexist, to share spectrum, and to be able to move rapidly out of spectrum when needed for those things. Hyperdimensional software-defined networks is a mouthful of a term, but it has to do with heterogeneous networks needing to work better together. And we live in a world where there's an environment with multiple control planes, multiple activities going on simultaneously, dissimilar networks that really do need to work better together. And so at many different dimensions as well. And so we could talk about that some more, but mobile IP is a bit of a misnomer, but privacy enhancing technology enhancements and mobile protocols that really enhance privacy and cyber are really very, very high on our list. Some of that's built into some of the work that's going on in the Open RAN world. Microelectronics for Future G, right? This is a big fund, $50+ billion fund that came out of the CHIPS Act, right? Where the US is setting up, they talked about setting up 6, I think they've set up 7 regional hubs around the US to work on kind of next generation. This is an area where the US industry by itself has a hard time really, jump starting in the microelectronics. It's hugely expensive. You need economies of scale. You need commonality of thinking to really drive things forward. Dr. Rondeau, our principal investigator, is the chairman of the wireless aspects of that. And so we're looking forward to working both simultaneously on the software development that you are talking a lot about here, and in parallel to that, developing some of the hardware, supportive hardware capabilities through the microelectronics commons that's being developed. A lot of you have, well, many of you are involved in it in this room, but I'm sure all of you have heard about that. And this is the best one. I mean, we started by calling it unlimited software-defined radios, right? I mean, how do we take the known limitations of today's hardware, and take things to the next level? I mean, the current software-defined radios have certain limitations in terms of bandwidth, physics. How do we begin working on that next generation, such that the researchers can just kind of drive behind us, right? Is that a long pole in the tent that we can knock out of the way, right? Lots of work going on there. I'd love to point out, David is in the back here. David Kirkpatrick. Where is David? Dolores, I want to point you out too, right? I have a couple of peers in the room. Dolores Schaefer has been running the 5G challenge, right? We have the RIC forum coming up. So many of you, I know there's a couple of winners of the RIC challenge in the room. Feel free to stand up, right? Who did some amazing things during that competition, right? But that was a prize competition to encourage, force, cajole people to work together on interoperability, right? And the RIC challenge is, we're not done with the plumbing work yet, and we're not building on a solid base to get to the RIC, but we wanted to have people elevate their gaze, and instead of focusing solely on the plumbing, look at where the innovation layer is. Look at what's possible once we get some of these lower level functions working well, right? How do we really take the RIC to the next level and show what's possible? And at least that was some of my thinking behind pushing hard for the RIC forum, which is kicking you off now. For those who might have thought you missed the deadline of today to file, they've just extended it another week. So if you've not submitted yet, you can fine tune your white paper, right, Dolores? Right. Is David here? Where's David? Just going to point him out. David from DARPA. Oh, I don't see him. I know he'll be in all day tomorrow, and so we can probably work through some of that, right? Look, this is, I would love to take questions during the break and over the next day. I plan to be here tomorrow all day. Would love to talk with folks about ideas. But this is the classic, tell them what you're going to tell them what you told them, and then get off the stage, right? But it's clear, right? Information integrity on the battlefield, we can't keep up anymore. And designing our own networks when there's this global platform out there that can do an incredible job is one of the key reasons we're focusing on leveraging commercial technologies. The 3GPP family of technologies is generations of innovation, right? Our innovation cycles are beat on a regular basis by the commercial industry, right? And we want to take advantage of that. The cycle times are extraordinary, and we're latching hold of it, right? We think that if we're smart about it, we pick the right dual use cases, we'll benefit as much as anyone else as we go forward, right? The transparency of open systems is fundamental to us, right? We're constantly dealing with the question about, well, it's open RAN, right? I mean, it's not secure, right? And there's a lot of studies that have been done, right? I mean, 5G is the best designed, it's the most securely designed network in the history of the world. But when it's implemented, it has security flaws, right? Both the traditional and the open RAN. A recent Quad report, which was published, shows that the difference between open RAN and traditional RAN in terms of security increases in surface or the percentage of threats that are perceived is something like 4%, right? We can deal with that. I deal with that any day if we have clear visibility to the interfaces and aren't relying on a third party to tell us what's going on there, because our people are more important than that, right? And so what's being done here really sets the stage for that. We're having to change how we do. Instead of doing things behind the curtain and secret, we still do a lot of that, right? But getting out there and learning how to talk to industry and learn the industry language and capabilities is a big part of what we've been doing. So you'll see we're working to adapt, and advance commercial communications to really benefit the warfighter and our nation, right? And so happy to talk more about the importance of software, the role that it has to play, right? I think I've said this, but I'll say it again, right? On areas we're big believers in zero trust architecture, right? 3GPP architecture is not optimally lined up for zero trust, and we don't feel we can push the industry too hard. We can work to convince the industry, and we can say that when zero trust becomes available to us, we shall buy it. And that's what we will be buying, right? So it's more of a market driver for those that are interested in the market, or those that really care about the national security or national economics of our country, right? We're pushing hard in that realm. The same thing with open systems. We have a dictate to the DoD from the DoD CIO that thou shalt, and this is paraphrasing, but thou shalt buy it when it's available, right? So when it becomes available and viable, that's what we're going to be buying. And we think that's a better message than, we really need you guys to build it for us, right? That's what we're going to be buying. That's what we're going to be using, because that's what we believe in, right? We know many of you believe in that too. So with that, I thank you for your time, and I'm open to any questions you might have.
Thanks very much, Scott. All good. Yeah. Any questions?
So when we talk about open RAN, we don't talk about UEs. I mean, for UE, we have to use commercial chips, right?
Yeah.
Do you have any strategy? I mean, maybe you're uncomfortable talking to foreigners.
Well, I mean, when we think about open systems, we think about open UEs, open RAN, open systems, open transport, open backhaul, right? Not doing a lot of work on many of those things, right? We've got to start somewhere. But open UEs is kind of the next step, right? We're focusing now on where we believe it's really important for innovation, for there to be a place for industry and others to innovate and really differentiate, right? And we hope it's at the feature level. It's at least in this next thrust, right? We're leaving the RU outside, so to speak, right? And we're focusing on looking at the CU and the DU. And we're looking for an end-to-end framework that contemplates that. I don't know that I answered your question, right? We're kind of building in the direction of the UE on the UE side of things, right?
I don't know whether you can implement using software.
So most people think of UEs as this, right? In the DoD, this is rarely seen as a UE, right? We have vehicles and missiles and sensors and other things, right? So, but getting to open source where it makes sense and when it makes sense is fundamental. Not a very good question, right? It's not an area we focused a lot on because where we see the power is at the network layer, right? And being able to intelligently leverage the network. And over time, we'll move more in that way. We have a lot of specialized network sensors. It's a big part of what we do, like blue force protection, those kinds of things. So I don't know that I've answered your question well, but our group's not spending a lot of time on the UE at this point, right? Yeah, unless it's a drone, right?
Okay, so we're a little bit over time, so we might leave it there, but let's thank our speaker. Thanks very much, Scott.
Thank you.